This episode of Perl deals with octal numbers, or base 8. And like before, we're going to start by revisiting our base 10, or the decimal number system. Remember, we use the digits 0 through 9. And when we put a number together like the one in the top row here, 4096, we interpret that as 4096. But why? Well, it's because each position represents a value. The rightmost position represents our number base 10 raised to the 0th power, or 1. So I have 6 ones. The second position equals 9 units of 10 to the 1st power, or 9 tens, 90. The next one represents 0 units of 10 squared, or 100s. We have no 100s in this case. And then the leftmost digit is a 4. 4 units of 10 raised to the 3rd power, or 4 thousandths. So we intuitively recognize this as the number 4096. Now, this is an 8-sided or 8-pointed star, or a shape of an octagon. And we are going to talk about base 8, or the octal number system. So we have the octal digits. Now remember, base 10, we had 10 digits, and base 8, we have only 8 digits. And those are 0 through 7. Now, if I take the number 173, or the characters 173, as an octal number, I'm looking at 3 units of 8 to the 0th, 7 units of 8 to the 1st power, or 7 eighths, and 1 unit of 8 squared, or the 64s. So the place values of those digits are 1, 8, and 64. So I have 3 ones, 7 eighths, and 1 64. And if you add those together, you get the decimal number, or base 10 number, 123. So we're saying that an octal 173 is equivalent to a decimal 123. Now, if I want to represent this number as a numeric literal in base 8 in Perl, I precede it with a leading 0. So this would be the octal 173, which is the same thing as a decimal 123, right? Now, you have to be very careful in Perl not to use a leading 0, because just that 0 at the leftmost position of a number automatically changes it to an octal number, which is an entirely different value. Nothing to it.